In this video, we are going to solve a problem involving a circle and the locus of a straight line. We are given some information about a circle. To visualize the given problem, let's sketch it out. Mark the approximate positions of A, 2, 0, and B, 8, 0, which circle C passes through. Then, circle C cuts the negative y-axis at M and N, while the y-coordinate of M is greater than that of N, so N is below M. Now we can sketch the circle and mark its center as G, and the y-coordinate of G is -5. Part A, we need to find the equation of C in the standard form. Let's try to find the coordinates of G first. What information can help us find them? Maybe A and B, whose coordinates are given? Here we need to use a property of circles. Remember that a perpendicular bisector of a chord passes through the center. So the perpendicular bisector of AB will pass through G. As AB is horizontal, its perpendicular bisector will be a vertical line. So the x-coordinate of G is equal to that of the midpoint of AB. The midpoint of AB is 5, 0. So the coordinates of G are 5, -5. Now we have the center. Let's find our radius. Both GA and GB are radii of C. We can find either one. Let's use the distance formula to find GA. GA equals the square root of 34. Then write down the equation of C in the standard form, which is x minus 5 squared plus y plus 5 squared is equal to 34. That's it for part A. In part B, we need to find the coordinates of M and N. M and N are points which C cuts the y-axis, so that x-coordinate is 0. So we can substitute x is equal to 0 into the equation of C to obtain a quadratic equation of y. Solving it, we get that y is equal to -2 or y is equal to -8, which are the y-coordinates of M and N. According to the question, the y-coordinate of M is greater. So the coordinates of M are 0, -2, and the coordinates of N are 0, -8. Part C. The straight line L1 passes through G and N. The straight line L2 passes through M and is parallel to L1. A moving point P maintains an equal distance from L1 and L2. The locus of P is denoted by gamma. For a moving point maintaining an equal distance from two parallel lines, its locus would be a straight line between the two lines, parallel to them, and maintain an equal distance from them. Part 1, we need to describe the geometric relationship between gamma and L1, which we already did. Gamma is parallel to L1. In part 2, we need to find the equation of gamma in the general form. Since gamma is parallel to L1, the slopes of them will be the same, so we can find the slope of L1 instead. Can we find the slope of L1? Sure. We already found G and N. So the slope is 3/5. Then, do we have any point on gamma? As gamma maintains an equal distance from L1 and L2, we can prove that these two triangles are congruent. We can then deduce that this side is equal to this side, as they are the corresponding sides of the two congruent triangles. So the y-intercept of gamma shall be the midpoint of MN. We've already found M and N, so we can find the midpoint of MN, which is 0, -5. Finally, using the slope-intercept form, y is equal to mx plus c, the equation of gamma is 3x minus 5y minus 25 is equal to 0. That's it.